Um, in this talk, I'm going to talk about my experience as a full-time inventor, and I will demonstrate it with patents related to sight. I've given talks before on patents in other domains like for blind people or dancing or augmented reality or software testing. This one will be related to sight, and I hope it will be interesting. I will discuss four domains. The first one will be patents for the blind people, and this is not actually related to sight, but this is how you replace sight with technology. Then I will talk about what it is that you can learn by looking at the eyes. It's actually very interesting. With eye tracking, you can do all sorts of really interesting things. Then I will talk about augmented reality, which is how you enhance your sight of the real world with the augmented world. And then I will conclude by talking about security. Once somebody can show us augmented world, maybe can also attack us in various ways, and how can we protect ourselves. So a little bit about me. I did my master's in the Technion. I did my PhD in Carnegie Mellon. One of my advisors was Herb Simon, who had a Nobel Prize Turing Award and a von Neumann Award. And the second advisor was Mike Trick, who is the dean of the Industrial School of Administration in Carnegie Mellon. Then after finishing my PhD, I started working at IBM Research. I was given quite a number of things to choose from, and I chose to work in software engineering, particularly in the area of testing. In addition to working on software testing, I became an IBM Master Inventor, which means that my job was, in addition to having about 50 patents at the time granted, I would help people invent. So people would come to me maybe twice a week from either IBM Haifa or anywhere in IBM related to software engineering, and I would help them with having patents. I was a very generic inventor. About 50% of my patents were related to my work, and the other 50% were on random ideas I've been thinking about. I quit IBM and in 2010, and I had no specific idea what it is that I plan to do next. My first thought was to be a professor at the university, as I had enough publication to go there. And I also started several startups using my inventions. For example, ViaVision, which is described here, started as an invention we tried to sell. And when we couldn't sell it, I didn't know what to do. I didn't have a client, but the person who co-invented it with me said, "It's a great idea." I said, "Fine." I said, "It's a great idea." I said, "Fine." He said, "We need to start a startup." I said, "Really nice." And he started the startup based on the ideas that the client didn't want to buy. My first invention was in 1993. I invented invisible printing. What I noticed was that with the new printers that were coming at the time, the matrix printer, the laser printers, a single dot was very small. So if you make a pattern of dots, it's practically invisible. And you can write things on the paper, and this is really useful. For example, you can write the name of the printer that is printing the paper, and then if somebody finds the paper anywhere, he will know the name or the name of the file. Or you can use the idea to protect software. The university, Carnegie Mellon, which had the rights for the patent, decided it has no value, so I decided to go after it myself. And I made many, many mistakes because it was my first patent. So this was a very valuable patent, and the reason I think it became so valuable is that the US decided that every printer should do it, which means that the entire industry is doing it, but unfortunately it was my first patent, so I didn't know how to do it. I made many legal mistakes and many business mistakes, and this is the reason I now teach inventors about making money out of ideas. So you have many ways to make mistakes, and no reason you make mistakes that other people made. So you can study from me and from others and if you're an inventor, be original about your mistakes. Don't make the mistakes that everybody else does. Most inventors lose money. Actually, the main problem is that if it's an idea that you have, you think it's a great idea, and you're willing to spend a lot of money to make it happen, you'll file a patent and you'll make a prototype and you'll do a business plan. And generally, the idea is not worth it. So you need to learn how not to lose money. And I consider myself a professional because I make money from ideas. Another problem is about the way the patents are written. So even if the idea is useful and valuable, the patents itself may be written in such a way that there is no way to infringe it, which means that you'll not be able to make money, or you don't have the right route to market to make it happen. Okay, so enough with my story, and now I'll talk a little bit about patents. When I left IBM, as I said, I had to decide what it is that I do. I decided that I'll become an inventor, and I wanted to make sure that my invention has nothing to do with IBM, because I was a master inventor in IBM, and then they might have considered that it's theirs. So I decided to invent in an area which is not related to IBM, and the idea that I chose was dancing, which is one of my hobbies. And I was thinking, what is it that I know about dancing? And what I know about dancing is how to lead. How to tell my partner how to move without using any force. Of course, if you use force, you're not a very good dancer. And also very accurately. So, so I decided to invent something to do with leading, and then I thought leading could be useful for blind people. Blind people have two different technologies, both of them are 100 years old, for figuring out how to go from place to place. The first is the cane. And the cane is a way to figure out what's going on in the world. There are many other technologies now, new technologies for figuring out what's going on in the world, but all of them are basically the equivalent is that we try to tell the blind person what is about him by replacing the sight by some technology. The cane is actually extremely popular and useful. The second technology is the dog. So you have a dog, and the dog is extremely smart. And the dog, you can tell, take me to the supermarket, and the dog takes you to the supermarket, which means that you can get to the supermarket, but you're limited because while the dog is smart, you can't tell him, take me to Joe, if he doesn't know where Joe lives. If he knows, if he was taught, then he will take you, but if not. When they choose the dogs, they make sure that they are smart. One of the things that they do, for example, is that they when the dogs are in the kennel, some people come and give treats to the dogs who are not asking for it. So a dog has to look around, figure out that the dogs that are not asking for it are getting the treat, and figure out that when this person comes, he's going to just sit quietly and get a treat without asking for it. So for those of you who have small kids, think about how many of your small kids would actually be able to observe, make this observation. So those are smart dogs. So when I was looking at it, I was thinking maybe I could teach the dogs. They learn all sorts of things. To teach them to lead a large step. And a large step is useful because instead of walking around the banana, for which you need all the space of 90 centimeters around, you see the dog is right next to you, you can walk across it like an exciting person does. And leading a large step is actually not difficult. But when I was trying to convince them to use this new knowledge to teach the dogs, they were laughing at me, saying, I'm trying to teach the dogs to dance. So people thought, well, if there is a dog, maybe we can replace it with a robotic dog. And what you see is a picture of a robotic dog. And a robotic dog, of course, can use GPS and go places, but it's extremely expensive. Because you have to have a robot there and it needs to be able to navigate. And we actually don't need that because while the people are blind, they can walk. So you don't need a dog, you just need the technology, the sensors that tells you what to do. So what I did is I thought let's assume that the dog or somebody develops the sense of where to go. Google Car, for example, is an example here that somebody did it. And what I want to do is tell the blind person how to move his legs, which is what I do at dancing. So I developed a technique which is not based on sound because I don't want to tell him he needs to listen to the word. So it's a haptic, and basically it's a belt with 6 transducers, and we use it to tell the person how to walk and also how to move the hand. Moving the hand is very important um, because, for example, you are next to a flat screen and somebody reads the flat screen to you and says there is a red button to press to go to Jerusalem and another green button to go to Carmiel. So please press the red button. And as a blind person in front of a touch screen, you can't, or you want to press to get to the 4th floor. So you want to be able to lead the hands or the legs. What I'm going to show you now is at the beginning of the experiment, I hired a dance instructor and a dancer. The dancer happened to be her mother. And they were practicing learning. What you're going to see in the next very short video is she has to tell her to move her legs to touch on the green things and not to touch on the black things. So you can see the accuracy, which is total different accuracies than a dog leading you. You can actually tell the legs where to go. You can actually cross a river. You can do all sorts of things if you learn the technique. So hopefully we'll see the movie now. Okay, skip the movie. Okay, so eye tracking patterns. So eyes are, in some sense, a door to your brain. When you think, your eyes move, and they move in a way which reflects the way you think. Most people are not trained to control their eyes. So what is it that you can do with this observation? The first thing that somebody asked me to do when I left IBM was to be able to find people who lie at the airport. And I could not figure out people lying. This is a hard problem because people have been thinking about it for a long time. So what I thought was I will track the eyes and figure out, I will show you a picture and figure out if you actually know the person in the picture from the way your eyes moved. And this is useful because if somebody you think belongs to some organization, you show him somebody from that organization, and if he knows him, then you might want to interrogate him further. So I found an article in the paper that shows, that did research that shows that if you know a person, you look more at the inside of their face and less at the outside. And if you don't know, you look more at the outside. So I thought I could do that. And actually, we started a startup based on this observation and being able to show, but we will not be able to replicate this result. And the reason we could not replicate this result was that it wasn't just not true. Other people tried to replicate it. You have hardwired in your brain ways to identify faces. You might look at left eye, right eye, and then the mouse, and you'd be doing the same for every person. So it just doesn't work. Okay, so this didn't work, so we have to figure out a different way to do it. And then I thought about the following way. What I'm going to do is I'm going to show you 2 pictures and ask you if it's the same person. So there are 4 possibilities. The first possibility is that you know the person and you're not lying. So what you do is you look at the left, you say this is Chaim. You look at the right, you say this is not Chaim. So you say it's not the same person. Or you say it's Chaim and Chaim, it's the same person. The second option is that you don't know the person and you're not lying. So we are talking about not lying, and then your eyes move from nose to nose, from mouth to mouth. You're trying to figure out if it's the same person or not. So it's very easy if you're not lying to figure out by eye tracking if you know the person or not. When I give you this task, I just say if you jump from place to place all the time. But what about if you're lying? I mean, those are the people we want to catch. So if you're lying, there are 2 ways to lie. The first is you don't know when you say that you know, but this is kind of a stupid lie because then I can ask you who it is. So the only case that is interesting is that you actually know, but you're trying to pretend that you don't know. And what you do is you jump with your eyes from place to place, looking as if you don't know, and you're trying to figure it out. Turns out that you can't control your eyes well, and if you know, they move in a totally different way than if you don't know. And the nice thing about this is that I don't have to figure out the algorithms. What I do is I train people, I check people that know, and I check people that don't know. And then I have the patterns, and then I use deep learning, and I can say the magic happens, and I have a pattern of how to figure out if you know a person or not. So, so those are the four possibilities, and we can figure out where you are with 95% possibilities. The startup was working, the technology was working, but the business case didn't work out for this particular startup. So they came, and then they came to me with different questions. They said, we want to do some idea for the mode testing. So the problem with the mode testing is the following. You take a class in IBM. Let's say you take a class in MIT, and then you take the class remotely, and then you want to also take the exam remotely, which is fine. But how do we know that you don't cheat? So the first thing we do is we put a camera, we use the cameras that you have on your phone, and then we know it's you there. But then the second question, you can still cheat because somebody can be sitting next to you and telling you the replies. So what we do is, or what MIT does, is they put this revolving camera that you're supposed to put on top of your laptop, which looks around the room and trying to find the person who's hiding to tell you the results. But of course, it could be hiding under the table. You're setting it up yourself in your home. It's hard to know. So what we want to actually know is if you are thinking about the reply or somebody else is. So again, we go to the same idea as before. What I do is I take the patterns of the people looking, and it turns out that the pattern of the people who understand the exams that they're reading is very different than the patterns of the people who don't understand. They look more at the important data, they look more at specific kinds of the questions. And then I can split the people into two kinds, those who understand the exam and those that I don't know what they're doing. It's possible that they don't understand the exam. It's also possible that they just eyes move in a different way. They might have some eyes issue or whatever. So for those people, I ask them to go get tested in a place where I can watch them. But this will be less than 10% of the people. So we solve the problem of remote testing. But of course, you can learn lots of other things if you look at that. So for example, if you take people who are really, really fast, you need to go be fast for college entrance exams. And then you see the patterns that they use, and you see the patterns that people that are not so fast use, and you teach them how to become faster. The next picture was taken by me in Buenos Aires when I went to dance tango. And what you see is the time before the dance will be 10 minutes of 10 dance, it's called a tanda. It's the time of the cortina, and this is the time where every person has to find a partner. And the way it works in Argentine tango is you find a desired partner, and you see the women are sitting separately from the men, and you stare at her direction, and hopefully she also thinks that you're desirable, so she stares in your direction as well. And then after you do that for about 2 seconds, you nod with your head, which is why it's called the cabeceo, and she nods with her head, and then hopefully you agree that you're going to be dancing together, you come to her table and you invite her. You can realize this is actually very, very complicated because, for example, the women are sitting 3 deep. So you're starting from the other side, and it could be she would have a hard time knowing if it's her or not, and you would not know if he is replying to you or the person next to you. The first thing you can observe from this picture is it's taken from my point of view, and you can see that I am sitting in the sort of like the undesirable area of the milonga, of the place, and no woman is actually looking in my direction, which means that I don't have any chance. The sitting depends on the host who likes you or not, or knows you or not. I was, of course, a tourist. Okay, so we figure out what cabeceo is, and now I want to make money out of it and invent a patent. What can I do with it? So if I have glasses with eye tracking on me, which people will start having soon because of augmented reality, then my glasses know where I'm looking. And the glasses of the other person know where I'm looking, so the 2 glasses would actually know if we are looking at each other. So assume that I'm in a loud party and I'm looking at somebody from 6 meters away, and she is looking back at me, then the glasses can figure it out and start a phone call between us. So if we are looking, which isn't a natural look, I mean, we all both look at each other for more than 2 seconds. People generally don't do that. Then basically a phone call will start and we can talk even though we're 6 meters away and there is loud music. So what we see here is that if you know something, for me it's really important. If you know something in one field, it's useful in others. And it's almost always the case that you could, if you find something smart, you can see you can find some interesting use for it. Move from the area of looking at the eyes to augmented reality. And we're going to discuss what will an augmented reality skin shop look like. So a skin is an augmented reality application, one that does something, and we have app shops with millions of apps, and we're going to have skin shops for our augmented reality skin with loads of skins. So what's the difference? Why am I even? So let's first figure out what can be a skin. So for example, you can modify the surrounding. In this case, it's what we see is a skin that does navigation for you. And navigation currently is in the phone, but here it will be on the world. It shows you where you're supposed to go. It could show it in this way. It could be a horse that you're chasing. It could be anything. But basically, it modified the surrounding to make it more functional, or it could be just to make it more appealing. Another one is one in which you have translation. So you are walking, you have glasses, and the language is always English, regardless of the countries that you're in. It translated, and you don't even see the original. You just see it in English. Another one is that you have a user guide. You are supposed to change something in your car, and it tells you what it is that you're supposed to do, where to move your hands, and what it is to do. So there are all sorts of. And the skins shop must integrate those skins. You can't do them themselves because it's quite likely that many of them will be happening at the same time. For example, you're traveling in a different country. You actually need the translation and the navigation to work simultaneously. The other thing is that we assume is that almost everyone will have the AR glasses. For me, for example, I tried to resist using a smartphone for a long time until on the same day I was in the university and I wanted to get a password for my laptop. So I did everything I needed according to the server, and then they said, give us your number and we'll send you an SMS, and I didn't have a phone. And then I returned home and I couldn't enter my village because you have to open the gate with a phone. So I needed to have a phone and I got a phone. So think about everybody having an AR glasses, then a lot of the information will not be in the real world, but will be just in the glasses. And if you don't have it, you don't know what's going on. The second thing that happens is that you probably have tens of skins that are active at the same time. They might complement each other in different ways. So for example, one skin will add a hat, and the second skin does something to the hat, so you have a specific hat. And what we see from the first is that the order is important. So because they talk to each other, it's not like an app store where you can create an app. You have to create a skin that actually talk to other skins. Now, generally, you don't know what other skins people have, so how can you make them communicate? And the way you do it is, or the trivial way to do it, the one that's likely to be used is you start with the real world, and then you add a skin, and then you add a second skin, and the second skin applies itself to the result of the first skin. It doesn't know if it's the real world or not. So, for example, you have the first skin add beards, and the second skin change beards to be blonde, so the person will have a blonde beard. Okay, so now we figured out how a skin shop should work, and the question is, what's the problems? What is it that you need to do to make it actually work as opposed to just basic idea? So the first issue is you have to figure out in which order to apply the skins. Now, assume you have 50 skins and you get a new one, and it will operate differently if it's in number 17, number 32, or number 56. So how do we figure which number it is? And we know it's totally unreasonable to ask you to ask you to place it in a specific number. We have to help you figure out how this is done. The second issue is in all the skins have to work together from beginning to end in less than 1/50th of a second, so you don't get a headache because the image does not fit the image of the real world. I mean, if you add the beard to a person, after half a second, he is moved and the beard is not at the right place. So, so what if you have 100 skins and they don't manage to do it in 1/50th of a second? Which of them do you decide not to let work? You have to figure it out. If a skin wants to work on dogs, does he has to figure out if there's a dog in the picture or just he registers and say, if there is a dog, then on the dog I want to do something. So to make it run efficiently, you have to do something. Hopefully not all of them have to look at the picture, or very few of them do. So you have to create a framework and figure out how this works. What about you walk around and there is some glitch? How do you know which skin did it? How do you test and debug them? How do you protect yourself from them, from making the mistake? And what happens if you want a non-programmer to write skin? Do you have a language for that? So basically, I figured out all those questions, and questions are really delightful for me. And once I have the questions, then I can reply to those questions. And so I had 8 ideas to how to manage a skin shop, and I sold 4. Now, I already talked about selling an idea. I want to say this market exists. It's not a common market, but an actual idea, a 3-pager, can be sold. I sold more than 60 of, I sold about 60 of them, I guess. And usually you get about maybe $10,000 to $15,000 for the idea, depending where you sell it. Okay, so we discussed augmentation, and now, okay, so you're driving and your augmented reality is on, and does that work? So you have an AR glasses, which really works nicely, and that means that if you had one, you wouldn't know if I'm here giving the talk or I'm adding through your augmentation. So you have the AR glasses, you don't know if something is part of the real world or part of the augmentation. And you have all sorts of skins that are running. You translated, you have translation, and you have things that do for fun, like you change dogs to cats. And you decided that today you want to fill in the countryside, so the road is going to be covered with grass, and the cars are going to be changed into chariots. And the clothing are going to be the clothing of the Victorian area. So you are driving around, but everybody else is in a chariot, and you are on grass, and the people are nicely in their Victorian clothes. Okay. And of course, your GPS is working, and your translation is working, and everything is fine. So you're driving with your air on. You have a problem if you want to turn it off. What is it that you do? So the question is, can you drive it with on? Can you drive it with off? Problem. What if some of the apps are actually malicious? They want to cause you to have an accident. For example, if a kid is running to the road only in your own street, he will be erased, even specific kids. So maybe you don't see a kid from your family. That could be really, really bad. You've been looking, but he was erased in augmented reality. The opposite is also could be really bad. You're driving and a kid runs into the road. There is no kid, and you try not to hit him, and you turn into an accident. And it's possible that it's not even malicious. It's just a bug. So you covered the road with grass, but there was a pothole in the road, and it's also covered with grass because of the bug. It doesn't show you the pothole, and you hit it going too fast. So maybe it's too dangerous to drive with AR. How can you protect yourself? You can't trust the applications. So the question is really important, and the reason the question is really important is that if I would give you a few hours, you would solve it, and the solution is something that almost, well, not everybody, but lots of people can get to a solution. But getting to a good question is difficult. So, for example, in this particular question, the way I solve it is there are two images. One of them is the image of the real world, and the second one is the image of the augmented world, and the application cannot impact the fact that I know them. So the augmented world is, of course, very different from the real world, and the question um, is the augmentation going to cause me to have an accident or going to change the way I drive? And the way I figure it out is what I will do is I will take self-driving software and I will run it both on the augmented and the real world. And if the change is one that does not cause a change in the drive, for example, you change the road to grass and it's fine, or you change the sky to blue, or maybe you change a dog to a cat, even dogs that runs into the road, then it's fine. They drive in the same way, and I don't need to do anything. But if they're going to drive in a different way on the augmented world than the real world, then the augmentation caused me to change the way I'm driving, and there is a risk because I do want to drive in the real world. I will remove all the augmentations and continue to drive, and this way I will be safe from bugs as described here. So this was an idea of using a reference model. It's actually an idea from testing. You use a reference model and you compare the real world to the augmented world. I'm going to show you a different way of doing something with a reference model. So you're watching Champions League, and you want to tell Messi what to do because obviously he doesn't know well enough how to play the game, and you want to give him advice. And usually you're just shouting at your TV and he's ignoring you. But can you make it actually useful? Can you actually do something? So the first thing that I do is when I want to give Messi an advice is I would I would press on my TV, and then I would see the game twice. Nothing very interesting, I just see the game twice. Now, when I want to start telling Messi what to do, what I'm going to do is I'm going to have on the right, instead of the real game, I'm going to have a FIFA game. You see it looks the same. The players look the same and everything, but this is a computer game. It's not the real game. And in the computer game, I can tell Messi what to do. And when I tell him what to do, of course, all the game becomes very different. The other people react to the fact that Messi is doing something else. And maybe 30 seconds later, we will find that the games have nothing in common, and I will just kill the game and continue to watch the real game. And in the end, I would be able to ask questions like which Messi is smarter, me or the real one, according to all sorts of statistics. When I was interviewed about my inventions in Buenos Aires, this was the title, which says Shmuel Ur, the Israeli inventor who could control the movements of Lionel Messi. They thought this was a funny title for the article. The next patent is here in this talk because I'm giving a talk in Google, and I want to say something about the future of search. So we're going to talk about augmented reality and privacy. So the problem is the following. People have augmented reality. People are walking around with glasses, and they're sending it backwards for all sorts of processing. And now let's say Google or whomever gets this information has the real world, the information about the real world in real time of all the cameras that are moving around, which is a huge amount of information. And now I'm going to use it to find things in the database. The database doesn't want me to know. So I invented an attack, which is a context-based attack. And and I'll explain the attack. And the attack is against the big brothers that know everything there is to know. So what's a context-based attack? When you see this picture, you can't know who the person is. Just not enough information. You don't see the face. But had he been sitting in his desk in your office, you would know. If it was in your house, you would know. If you walked around with him and he turned around, you would know who it is because you have context. You know, it's not a random person in the entire world. It's you go into the office, you see a person from very far away, and you know who it is because out of the 30 people in your office, this is the only person that fits this information. So my idea is the following. What I'm going to do is I'm going to tell the company that I took this picture of this person now, and I'm asking who it is. If they can identify him, and they tell me this is Chaim, then I know that Chaim is in the area, otherwise I won't be able to identify him. There is just not enough information. If they use only the information they have, basically doing face recognition and not using context at all, then they have a problem that the identification is not very good, much worse than the human is in most conditions. So this is the problem that I want to address. And while I can't patent the attack, I can patent the defense. Defense is not important here, but we have to decide how to protect from this context-based attack. I just want to mention another thing is, I assume you're familiar with the Google effect. And the Google effect says that if you can search something on Google, you are less likely to remember it. So for example, our generation know a lot less phone numbers because we can find them on the phone. We just type the name and we know the number, and the number comes up. So what happens if you have augmented reality glasses, and when you watch somebody, they can figure out that you forgot the name because you are thinking and your pupil dilutes, and then they tell you the name. So now you don't need to remember the name and you don't need to remember the number. And let's say that half an hour later you want to call him. So how would you do that? You don't know both. So what you could say, you have very smart glasses and a very smart computer, and you could say, I want to call this person that I met half an hour ago, and he told me something about Carnegie Mellon. He's a bright guy. I want to call him. That's not very efficient. So you have to be careful about giving so much information with augmented realities that will make the brain less useful.